What is electricity? Any appliances that we use in our daily lives, such as household appliances, office equipment, and industrial equipment, almost all of those take electricity. Therefore, we should understand electricity. The first question that we will find out the answer is, where does electricity come from? All matter is made up of atoms. Then you will ask the next question, what are atoms? Atoms are the smallest part of an element. They are composed of nucleus and electrons. Electrons surround the nucleus. Elements are identified by the number of electrons in orbit and around nucleus of atoms, and by the number of protons in the nucleus. Nucleus is made up of protons and neutrons, and the number of protons and neutrons are balanced. Neutrons have no electric charge. Protons have a positive charge, and electrons have a negative charge. The positive charge of a proton equals to the negative charge of an electron. Electrons are bound in their orbit by attraction of protons, but electrons in the outer band can become free of their orbit by some external forces. These are referred to as free electrons, which move from one atom to the next. Electron flows are produced. These are the basis of electricity. Material that allows many electrons to move freely are called conductors, and material that allows few free electrons to move are called insulators.
All matters are made up of atoms that have electric charges. Therefore, they have electric charges. For the matter that has a balanced the number of protons and electrons, positive charge force and negative charge force are balanced. It is called neutral state of an atom. The number of protons and electrons remains equal.
Static electricity. Static electricity represents a situation that all things are made up of electric charges. For example, the rubbing of material against another can cause the static electricity. Free electrons of one material move forcefully till they are freed from their orbit around nucleus and move to another. Electrons of one material decrease. It presents positive charges. At the same time, electrons of another increase, and it has negative charges. Current, voltage, and resistance. What is current? An electrical phenomenon is caused by flow of free electrons from one atom to another. The characteristics of current electricity are opposite to those of static electricity. Wires are made up of conductors such as copper or aluminium. Atoms of metal are made up of free electrons which move freely from one atom to the next. If an electron is added in wire, a free electron is attracted to a proton to be neutral. Forcing electrons out of their orbit can cause a lack of electrons. Electrons which continuously move in wire are called electric current. For solid conductors, electric current refers to directional negative to positive electrons from one atom to the next. Liquid conductors and gas conductors, electric current refers to electrons and protons flow in the opposite direction. Current is flow of electrons, but current and electron flow in opposite directions. Current flows from positive to negative and electrons flow from negative to positive. Current is determined by the number of electrons passing through a cross-section of a conductor in 1 second. Current is measured in amperes, which is abbreviated for amps. The symbol for amps is the letter A. A current of 1 amp means that current passes through the cross-section of two conductors, which are now placed parallel. A current of 1 amp means that current passes through a cross-section of two conductors, which are placed in parallel 1 meter apart with 2 by 10 to the power of -7 Newton per meter force occur in each conductor. It can also mean charges from one coulomb, or that is 6.24 into 10 to the power of 18 electrons, passing through a cross-section of a conductor in 1 second. What is voltage? Electric current is a flow of electrons in a conductor. The force required to make current flow through a conductor is called voltage, and potential is the other term of voltage. For example, the first element has more positive charges, so it has a higher potential. On the other hand, the second element has charges that are more negative, so it has lower potential. The difference between 2 points is called potential difference. Electromotive force means the force which makes current flow continuously flows through a conductor. This force can be generated from power, generator, battery, flashlight battery, and fuel cell, etc. Volt, which is abbreviated to V, is the unit of measurement used interchangeably for voltage, potential, and electromotive force. 1 volt means a force which makes current of 1 amp move through a resistance of 1 ohm. What is resistance? Electrons move through a conductor when electric current flows. All materials impede flows of electric current to some extent. This characteristic is called resistance. Resistance increases with an increase of length or decrease of cross-section of a material. The unit of measurement for resistance is ohms, and its symbol in the Greek letter omega. The resistance of 1 ohm means a conductor allows a current of 1 amp to flow with a voltage of 1 volt. All materials are different in allowing electron flows. Materials that allow many electrons to flow freely are called conductors, such as copper, silver, aluminium, hydrochloric solution, sulfuric acid, and salt water. In contrast, materials which allow few electrons to flow are called insulators, such as plastic, rubber, glass, and dry paper. Another type of material are semiconductors. They have characteristics of both conductors and insulators. When they allow electrons to move while being able to control flow of electrons, examples for these are carbon, silicon, and germanium, etc. The resistance of conductor depends on 2 main factors as the following. Number 1 being types of material, and number 2 being temperature of material. How to measure current? The instrument used to measure current is called ampere meter or ammeter. Steps for current measurement. Connect a small light bulb to a dry cell. Measure the current that passes through the light bulb by connecting positive terminal of ammeter to negative terminal of a dry cell. Safety instructions for current measurement. Number 1. Estimate current that requires measuring, then choose a suitable ammeter, since each ammeter has different limits of current measurement. Number 2. Be sure that the connection to positive terminal and negative terminal of ammeter are correct. Number 3. Do not directly connect the ammeter terminals to a dry cell terminal, since it can damage the meter. How to measure voltage. The instrument used to measure voltage, difference potential, or electromotive force is called voltmeter. The steps for voltage measurement are: connect a small light bulb to a dry cell. A voltmeter is wired in parallel with the light bulb to measure voltage across the light bulb. Connect the positive terminal of the voltmeter to the positive terminal of a dry cell, and connect the negative terminal of a voltmeter to the negative terminal of a dry cell. Safety instructions for measuring voltage. Estimate the voltage that requires measuring and then choose a suitable voltmeter. Since each voltmeter is designed with the limit of voltage measurement. Number 2. Be sure that the connecting positive terminal and negative terminal of the voltmeter are correct. How to measure resistance. The instrument used to measure resistance is called test meter or multimeter. The multimeter or test meter is used to make various electrical measurements, such as current, voltage, and resistance. It combines the function of ammeter, voltmeter, and ohm meter. Steps for resistant measurement. Turn the phase dial to a position for required measuring resistance, then touch both of the terminals of the multimeter and adjust the meter range to 0. Touch both of the terminals of a meter to a resistance and take the reading. How electricity works. Electric current is the ability to do work. Electric current can be converted to heat, power, and magnetism, to name a few. Electric current is classified by its function, and three primary types are: number 1 being heat and power, number 2 being electrochemistry, and number 3 being magnetism. Heat and power is used to make heat and power. For example, current carrying nichrome wire. That nichrome wire has high resistance and creates heat. This is applied to be components of electric ovens, toasters, electric irons, and light bulbs, etc. An experiment is made by measuring heat quantity of water by a calorimeter. Increase voltage across wire by the variac and connect ammeter and voltmeter to measure current and voltage. Set the variac scale to adjust voltage and current value of nichrome wire, and current is passed through periodically, and measure heat quantity from nichrome wire. There are any indications of voltage and current. If voltage, current, and time increase, heat quantity will also increase. They are expressed by relation as below. Heat quantity equals 860 multiplied by V, that is voltage, multiplied again into I, that is current, and multiplied again into T, that is the interval of time. This is called Joule's law. Heat quantity depends on voltage, time, current, and interval of time. From Ohm's law, V, voltage, equals I, current, into R, resistance. Therefore, heat quantity is equal to 860 multiplied by I to the power of 2 multiplied again by R into T. Heat quantity depends on current squared times resistance and interval of time. When current is passed through nichrome wire in water, current is converted to heat, and the temperature rises. Work is done by heat generated in an electrical circuit, which is called electric power. Electric power is equal to heat quantity. Electric power is measured in watts-hour, and heat quantity is measured in calories. Electric power equals to voltage into I, that is current, into time, which is T, which means V into I into T. Work is done by heat generated in an electric circuit is written in power, which it means that the rate of work is done in a circuit when 1 amp flows with 1 volt applied and its unit of measurement is watt. Power is equal to electric power divided by T, that is time, which is equal to V, voltage, into I, current. The conclusion, P is equal to V multiplied by I, B is equal to V to the power of 2 divided by R, P is equal to I to the power of 2 into R, W is equal to P into T. Electrochemistry. For example, when current is passed through sodium chloride solution, a chemical reaction called electrolysis occurs. This is applied to produce electrolysis, galvanizing, and battery, etc. An experiment is made by soaking 2 platinum plates in molten salt. Connect batteries to 2 platinum plates. Current is passed through molten salt and produces chlorine bubbles around positive plate and hydrogen bubbles around the negative plate, since sodium chloride composes of sodium and chloride. Experiment is made by soaking 2 platinum plates in molten salt. Connect batteries to 2 platinum plates. Current is passed through molten salt and produces chlorine bubbles around a positive plate and hydrogen bubbles around negative plate, since sodium chloride composes of sodium and chloride. When sodium chloride melts in water, the elements are separated. Sodium has positive charges, while chlorine has negative charges, and these charges are called ions. The molten salt has positive charges called anodes and negative charges called cathodes. The state of separated elements is called ionization. If salt is melted by water, solution is available ions called electrolyte solution, and if current is passed through electrolyte solution, a chemical reaction known as electrolysis occurs. Magnetism. The example of this electric work is current-carrying wire. Magnetic lines of flux occur. This is applied to produce electric motors, electric transformers, and tape recorders, etc. Understanding the meaning of magnetism. What is magnetism? The compound formula of magnet is Fe3O4. All magnets have two characteristics. First, they attract and hold iron. Secondly, if free to move like the compass needle, they will assume a north-south position. Any materials have these characteristics. If any materials have these characteristics, they are called magnets. The characteristics of magnets are: every magnet has two poles, one north and one south. Opposite poles attract each other, while like poles repel each other. Electricity and magnetic field. When magnetic needle is placed near electric wire, which current is passed through, the magnetic needle turns on the direction of the current flow. Therefore, electric current flow also produces an associated magnetic force, or it is said that electricity is able to produce magnetic field. When a current-carrying wire coil is placed near an iron bar, the iron bar moves slightly. If the core is placed in a wire coil, the iron bar is attracted strongly because the core is soft iron, which conducts magnetic lines of force when current is passed through the wire coil that surrounds the core. The core becomes magnetized with high power that is called electromagnets. This function is widely applied for using in industries.